Hello, my wonderful students. This is part two. So the second half. You can't see the first half. We just finished the first half there. This is the second half of page 4 of the foldable for section 5.7. And we have I wanted to do this one because we haven't done one of these yet, but I wanted to make sure you guys understood because we've been doing only rational expressions that had a p plus 2 and not just a variable by itself. So I wanted to do one of these to make sure everybody gets one of these as well, because this will probably happen more often than not. All right, so our expression is 16 divided by p plus 6p minus 5 divided by p plus 2 equals to a constant, which is 6. Just like we did the other ones, the first thing we're going to do is we're going to find our LCD. So looking for our LCD, which everybody knows already, it's our lowest common denominator. And our LCD here is actually p plus 2 times p. Because the 6, remember, whenever you have a constant, you don't really need to worry about it because there's no fraction, there's no denominator that can make this undefined. So there's nothing here that can make an excluded value. So we only have to really worry about the ones that are over here. So we have our p times our p plus 2. So our p times p plus 2. That's going to be our lowest common denominator. All right, so same thing we do the other ones. We're going to actually multiply the lowest common denominator by to our expression that we're trying to solve, our rational expression, which is our p times, not capital P. It makes a difference. It's a lowercase p, not a capital P, p plus 2. And we're multiplying, multiply the LCD in order to, the main purpose of it is to clear the fractions. All right, so, excuse me. Clearing the fractions. So let's go ahead and rewrite our equation, multiplying the p times p plus 2. So let's do our p times p plus 2 times our first expression here, which is 16 over p, plus our p times p plus 2 multiplied to our second expression, which is 6p minus 5 in parentheses over p plus 2 in parentheses, and this is equal to 6 times our p, 6 times p is 6p, and then times p plus 2. You could also put this in parentheses, but if you see that 6 times p is just 6p, we can just leave it as that, like that. Alright, so we're going to go through first and find our common factors. We see here our common factor here is the letter p, or the variable p, so we're going to go ahead and reduce those out. The second one we have is our p plus 2 and our p plus 2 here. And then we're going to reduce these out. And this one doesn't have a fraction, so there's nothing really to reduce. So we're just going to leave it like this. Okay, so we still got to distribute it. But same thing like we did in the couple problems ago, we're gonna use the associative property multiplication and move the 16 out in front. So it makes it easier for us to distribute. So 16 times p plus 2. And this one's already in front, so that we have a plus p times 6p plus 5. This is going to be equal to our 6p times our p plus 2. So we'll go ahead and distribute these now. So we have 16 times p was 16p. 16 times 2 is 32 plus r. P times 6p is our 6p squared, and then our p times our 5 is our 5p. And this is going to be equal to 6p times p again. We have 6p squared, and then our 6p times 2 is, I put a 2, but it's actually 12p. Alright, so we're going to combine like terms first on this side, and then we're going to go ahead and subtract this side over. So if we have our 6p squared goes out in front, because that's the highest sorry, exponential value. And then we have our 16p plus our 5p, which is 20. That's that's supposed to be a negative here. Negative, which would make this a negative 5p. It's a mistake. I saw this one when I was doing this right now. Negative, negative, negative. So p times negative 5 would give you negative 5. So 16p minus 5p would give us an 11p. Sorry about that, guys. I do it too, not just you guys. We all do it. So that gets rid of this, and what's left over is our plus 32. This is equal to our 6p squared minus 12p. So now we're going to go ahead and actually subtract the right side over. So we have 0 on the right side. Or not subtract, we do the opposite operation, because we subtract this, we're just going to make a bigger p on this side. So we're going to add 12p here. It's the opposite of subtraction. And we're going to subtract 6p squared here. So we're going to put this one first, subtract 6p squared, but we're going to add a 12p. Oh my god, I did it again, sorry. I was like, this is not looking right. Because you see this here? I brought a negative down, but it's supposed to be a plus. So we are subtracting 12p here. Okay. No more mistakes, I promise. So we bring the plus sign down. We subtract the 12p. We subtract the 6p squared. And we move it to this side. Subtract 6p squared. Subtract 12p. And then nothing further constants on this one. So this side automatically goes to 0 because we're doing the opposite operations of what's going on here. And this one we have a 32. And then 11p minus 12p would be a negative p, adding, and then this would be 0. Alright, so I don't want to subtract the 32 over there because then we'll still have a negative p. So what I'm going to do is add p to both sides. And I get that 32 is equal to p. And I can use the equality saying that p is equal to 32. Alright, so this is our answer there. So let's go ahead and do our excluded values first. Excluded value, and we check our LCD, which is our p is equal to 0 because we're going to set them to 0, and then our p plus 2 equals 0. Well, this one's already done because p is already set to 0, and then we're going to go ahead and subtract 2 here, subtract 2 there, and we get that p is equal to negative 2. So p cannot equal. Sorry, I keep doing that, but it's hard to kind of write them when we're doing the lowercase p's though. Lowercase p is not equal to 0 and negative 2. So our excluded values are 0 and negative 2, which is good because we get our answer to be oh, excuse me. We get our answer to be p is 32, which is not one of the solutions we had. So we're going to go ahead and do our check now. We're going to do a check to that equals p is equal to 32. So we're going to go back to our original equation. We have 16 over p, which is 32, plus our 6 times 32 minus 5 over 32 plus 2 equals 6. Alright, this ends up being, well, I'll just leave it as 16 over 32. Plus our 6 times 32, 192 minus 5 is 187 over 34 and equals 6. So believe it or not, this does equal 6 equals 6. I'm not going to show you guys all the work for that because it's just adding fractions, but I'm just going to show you that this ends up being true. So this is a true statement. Okay, so that means that I'm trying to box this off. I was trying to figure out what I was doing. All right, so that means that we can write our conclusion. So therefore, p equals 32 is our solution. Because there's no extraneous solutions on it, you know, it wasn't an excluded value and it was a true statement. So it is our answer or our solution. Circle this as well or box it. All right, and that's the final part. This is the final foldable for section 5.7, solving rational expressions.